Y'all know what themes are? No, not memes, themes. Telling a good story depends on weaving together unifying themes. Fitting classes together makes some ideas a lot easier to learn, because it turns out that you've been learning the same ideas in different classes, but you've been calling them different things. In English class, themes are the central ideas a story is about, but themes go way beyond English class. Psychologists use themes to study human subconsciousness. If you find underlying themes in the things people say or do, that gives you clues to what they're trying to say or do. The decisions you make and the actions you take tell a story of your life. You can understand the story a lot better by understanding the ideas the story is about. Philosophy is the search for an understanding of the world. In philosophy, themes are divided between metaphysics and epistemology. Metaphysics are the founding concepts that philosophy is based on. Epistemology is the method of making discoveries or drawing conclusions. Those two themes of the philosophy are the origin of all the ideas in the philosophy. Science is a philosophy. It's an intentional, structured approach to finding connections among ideas. But at the same time, science is so different from any other philosophy that usually people talk about them as two separate things. Science is the systematic search for reliable information. It starts with metaphysics and epistemology. Then it builds up layers and layers of unifying themes. The metaphysics and epistemology lead to hypotheses and theories. Theories are first principles. First principles are unifying themes in branches of science, or in specialized fields within branches of science. The biggest, most important first principles are unifying themes that connect branches of science. This is science, philosophy, and English class all at once. Science shows us a story of the world that keeps getting bigger and bigger because it shows us new ways to see the world and to organize information in our minds. Metaphysics, epistemology, hypotheses, theories, first principles, layers and layers of unifying themes. The metaphysics of science is math. Numbers can be used to count and calculate physical objects, or they can be used all on their own. And the math always works the same way. That can be confusing at first because many people use the word metaphysics to mean mystical, mysterious stuff. But metaphysics is only mysterious if you assume the world is supposed to be so confusing you'll have to spend your whole life trying to figure it out. Think about it. What are these people saying? If your approach to trying to understand the world starts with ideas you can't understand, what are you really looking for? An excuse for not knowing what you're doing in life? A way to make other people feel like they don't know what they're doing in life? Unless what you mean by metaphysics being mysterious is that people need to find a good starting point for understanding the world, and you haven't found one yet. Many people talk about metaphysics as if learning metaphysical truths will change your whole life. They're right about that one. Learning about numbers changed all of our lives. We just didn't notice it at the time. Because we were 2 or 3 years old when we learned to count on our fingers, and back then, everything we learned changed our lives. The epistemology of science is a 5-step process. Science is the search for reliable information, but all of our perceptions are subjective. Feeling that an idea is true only means you believe that it's true. It might be true everywhere all the time, meaning it might be a fact, or it might not. To discover ideas that are true all the time, we have to triangulate among the perceptions of many people to find ideas that stay the same all the time. We do that by observation. You need to be able to look at something and take a photograph of it. Or otherwise, you need to start with a direct sensory input that you can clearly describe. So we can all start with the same reference point. Self-consistency. You need to show that this thing always happens the same way in the conditions you're making your observation. You need to show some kind of pattern to your observation. Universality. You need to predict how that pattern will continue in situations you haven't observed it. Then you need to look for it in some of those situations and find it. Reproducibility. Other people need to be able to follow your path from observation to self-consistency to universality and find the same things you did. Debate. People have to be able to ask questions to understand your discovery better or to try to disprove it. And you or someone else has to be able to answer their questions and refute their disagreements. Once you understand that 5-step process, you can look at it as a 2-step process of finding clues and making discoveries. When you take the step from observation to self-consistency, and you try to take the step to universality, you form a hypothesis. If reproducibility and debate prove the universality, your hypothesis becomes a theory. Many people who argue against science say that theories are just ideas. But they're talking about the way people use the word theory in everyday language. People say the theory is to mean the idea is. But that's not what the word theory means in science. A theory is a pattern of facts that explain a process and predict its outcome. The theory of evolution is the first principle of biology. Every big discovery that's been made in biology is a new discovery of evolution playing out. Observation, self-consistency, universality, reproducibility, debate, hypothesis, theory. A theory is a discovery of a pattern. When you think you've discovered a pattern, you have a hypothesis. Then you take measurements of the factors that contribute to the process and its outcome. After you take measurements of multiple processes and outcomes, you can compare the numbers to each other. If the numbers fit together the same way every time, it means you've discovered a mathematical formula that explains the process and predicts its outcome. That's what a theory is. Here's the equation everyone's heard of. E equals mc squared is the theory of mass-energy equivalence. The energy an object contains in its atoms is equal to the mass of the object times the speed of light squared. Your physics teacher would be glad to explain to you where those numbers came from. For many theories, it's easier to describe what happens in words. But there's still descriptions of relationships among numbers. Every time you heat pure water, if the air pressure is always the same, the water always boils at the same temperature. The math behind the theory of evolution is the differential survival rates of genes and of the characteristics they create. The members of a species who are the best at surviving and reproducing in their environment have the most offspring that grow up to be adults who reproduce. That means they pass on the most genes and their characteristics each generation. Theories are first principles because they're consistent patterns. We've gone from the consistent patterns of math to a reliable way of using math to look for consistent patterns in the world, to the discovery of consistent patterns in the world. Science is the systematic search for reliable information. Reliable information increases your understanding of cause and effect. Reliable information is ideas that represent reality accurately. Reliable information is the kind that you can use to make decisions and reach outcomes you want. If the information you have is reliable, it means you know what you're doing. So the decisions you make and the actions you take produce the results you want. If the information you have isn't reliable, it means you don't know what you're doing. So the decisions you make and the actions you take don't produce the results you want. You tried to make one thing happen, but instead you made a different thing happen. That's the definition of a mistake. Observation, self-consistency, universality, reproducibility, debate, hypothesis, theory. Science, technology, engineering, and math all depend on reliable information. But if you ask people in those fields why we need reliable information, you'll get different answers. That causes some confusion. So look for the themes in what people say to figure out what they mean. Math is the logic of numbers. Science is a mental tool for discovering reliable information. Science's only purpose is the discovery of reliable information. Because reliable information is better than unreliable information. Neither math nor science have real-life consequences. People understanding numbers and understanding the world doesn't make anything happen. Gaining knowledge and making decisions are two different things. To mathematicians and scientists, there's no time limit on discovering the truth. Because the truth is always there, no matter how long it takes to discover. Engineering uses the reliable information of math and science for inventions. Engineering only has real-life consequences depending on what people invent and how well their designs work. Technology is a lot different from math, science, and engineering. What do you have to know to drive a car? Driving is part physics and part gym class. You have to know what the different parts of the car do, and you have to use your muscle power and your reflexes to make the car do what you want it to do faster than anything can go wrong. If you see a child run into the street up ahead of you, you need to stop before you hit the kid, not after you hit the kid. You learn what the brakes are for intellectually, and you learn where the brake pedal is by muscle memory. It's two different kinds of information, and you need to learn them both to be able to drive safely. Technology depends on you making real-life decisions moment by moment. You always have a time limit. Sometimes it's seconds. Sometimes it's tenths of seconds. To drive a car safely, you have to internalize enough of the math, science, and engineering involved to be able to make the right decisions on the first try every time. Like how much you need to slow down to take a corner, or how much distance you need to stop when a traffic light turns yellow. If you want to be an airplane pilot, an astronaut, a paramedic, or a surgeon, you have to learn a lot more science down to the intuitive level. Now we come to a fork in the road. What does better science education mean in the 21st century? Does it mean more classes that focus on individual branches of science? That would make it easier for students to get jobs as scientists. But is a shortage of scientists really the problem in getting people to believe in science? Or does better science education mean teaching people more about how to see and use scientific discoveries in everyday life? Science education, and science communication are three different things. Scientists do experiments and make discoveries. Science educators teach science to students. Science communicators get people to understand and believe in science, whether they're students or not. Think about the technology side of science. If a child runs in front of your car and you slam on the brakes, how much reliable information goes into your decision? In addition to knowing what the brakes do and where the brake pedal is, you also know what happens to children when they get hit by cars. You know how they, their parents, and other people feel about that, and you know how you would feel about that. All of those things come together in your mind to make you feel that there's only one right thing to do when a child runs in front of your car. So you're going to make the same decision instantly every time. You don't learn to think about science that way from your science teachers. You learn that from your driver's ed teacher. When people debate the meaning of science, and we depend on scientists to explain what science is for, most of their first-hand experience comes from their careers as scientists. Doesn't that lose sight of how we use reliable information in everyday life? Anyone who depends on doing anything the same way twice depends on using reliable information to do it. Anyone who serves in the military trains to do the most important parts of their jobs under the worst possible conditions. Anyone who works in any kind of a job learns to use reliable information to do it. Because before you can make a business plan for how to make a profit selling a product or service, you have to figure out how to produce it consistently. So the discussion of why learning reliable information is important goes way beyond what scientists do for a living. What does this mean for environmental science? Back in 1968, the pioneers of environmental science tried to warn everyone what the environmental crisis was going to mean for their grandchildren's generation. If you're in high school now, in 1968, you were a line on a graph that predicted how big the world's population was going to get. Now you have names and faces and birthdays and Instagram accounts. The highest level of learning anything is learning to use it instinctively. That means you've learned it so thoroughly, you've made it part of your subconsciousness. You don't have to learn science that well to be a scientist, but you do have to learn some science that well to drive a car. What we call environmental science isn't just the quest for information anymore, because the environmental crisis isn't 50 years in the future anymore. It's here, now. We still call it science, but now we have a time limit on it. In terms of how we need to use science in the 21st century, now it's technology. We need sound environmental policies to protect the environment, and those don't get made by split-second decisions. But a split second is all it takes to get angry about something and want to argue about it. Many people in our country get angry or feel distrustful the instant anyone says the words environmental science. Now, 50 years after the discovery of the environmental crisis, people are still arguing about whether or not environmental science is even real. Observation, self-consistency, universality, reproducibility, debate, hypothesis, theory. Where else are Americans failing at processing information? What do you think racism is? If every time you see a black person, everything you think and feel about the world makes you want to reach for your phone and call the police, or reach for your gun or your handcuffs because you are the police, you've gotten on a path to making the wrong decision. You're treating the other person like they're a threat, even though you don't have any information about them that corresponds to them actually posing a threat to anyone. The psychology of instincts is a topic all by itself. But you know that when people reach for their guns, life or death comes down to split-second decisions. Learning about science isn't just learning to do experiments in science labs anymore. Now, it's learning to recognize science as underlying themes in history, literature, art, philosophy, and everyday life. It means learning to use reliable information to figure out what's going on all the time, not just in science class. That even includes religion. If religion to you means fitting together everything we know into a story of the world that you feel is true, that's what science is at the technology level. Whether you call it science, religion, or anything else, whatever you believe subconsciously is what you believe the most. Because that's how you make your decisions when you don't have time to think about what you're going to do. Every time you make a split-second decision that affects someone else, whether you're driving a car, pulling out a gun, or just smiling at one person but scowling at someone else, You're treating them the way you feel you should treat them, based on everything you feel is true, without taking the time to ask yourself if there's a better decision you could be making. As for environmental science, we do have a time limit on discovering the truth. Every time a flood, a tornado, or a wildfire destroys a city, it destroys the schools, the universities, and the science labs there. Scientists can't conduct experiments, submit papers to quarterly peer-reviewed academic journals, and cite their reference sources using proper MLA formatting while they're busy running for their lives. If you're in high school now, you're like the kid running into the street because you didn't know what you were doing when you were 0 years old. You didn't get to vote on what the world was going to be like when you were born. But the people who have been driving the environmental crisis car down your street for the past 50 years still haven't invented a brake pedal. Well, what are they going to do if you get 1,000 or 10,000 or 1,000,000 other kids to run into the street with you? That's not a traffic accident anymore. That's a protest march. In the 21st century, at the technology level, there's more to environmental science than just the environment. There's also the psychology and sociology of effective communication. That means getting people to see and feel the unifying themes between science and everyday life. Metaphysics, epistemology, observation, self-consistency, universality, reproducibility, debate, hypothesis, theory, first principle, layers and layers of unifying themes. This is science, philosophy, and English class all at once. This is Ezra Niesen. You've been listening to Our Lives Matter, a blueprint for an education system for the 21st century, Track 6. Visit my website at STEAMAPE.org. Science, technology, engineering, art, mathematics, activism, philosophy, and education. To hear new tracks every week. Thanks for listening.